two ends are connected to each other, then the device is called the toroid. It can be prepared by closely winding an insulated conducting wire around a non-conducting hollow ring. The magnetic field produced inside the toroid carrying electric current can be obtained using Ampere's circuital law. So magnetic field inside the toroid can be found with the help of Ampere's circuital law. Now to find a magnetic field at a point P inside a toroid which is at a distance r. So we have a point P which is inside the toroid. Okay, so point P is somewhere here inside the toroid. Okay, so somewhere here there is a point P inside the toroid. Okay, and it is at a distance small r from its center. So center is somewhere here. So distance of this point is r from the center. Now we consider a circle of radius r. Now we consider a circle of radius r, okay, with its center at O. So this is the point O as an Amperian loop. So this is an Amperian loop that can be considered here, green color dotted line. Okay. So we have considered an Amperian loop of radius r and center of this Amperian loop is O. Now by symmetry, the magnitude of the magnetic field at every point on the loop is the same and is directed towards the tangent to the circle. So the magnetic field is directed towards tangent. So this is the direction of magnetic field. Okay, it is tangential to the circle. Okay. Now, according to our Ampere circuital law, we can have integration B dot dl. It is a closed integration B dot dl, or we can say line integration of magnetic field. Now see, magnetic field B is a vector quantity, dl is also a vector quantity. Okay, so we have two vectors and magnetic field is directed towards the tangent. So this is the direction of magnetic field and small line element. Say for example, if we show it by a different color. So this is the small line element, green colored. So magnetic field B and small line element, say dl, they both are in same direction. So B dl cos 0 it will become, and B is constant everywhere. So B is same everywhere on this circle because the points which are there on the circle are at the same distance from the center. Okay, so magnetic field is same at each and every point on this Amperian loop, and B dot dl will become B dl cos 0. Now B is constant, we take out from the integration, and if you take the integration of this dl, so integration of dl, close integration, that will give you the whole loop or length of whole loop, which is equal to 2 pi r. Okay, so you can see this integration, okay, that is B is equal to, integration B dot dl is equal to B into 2 pi r that you are getting. As theta is 0, that is between the B and dl. Okay, if the total number of turns are n and the current is I, the total current through the loop is n into I. Now you can use the Ampere circuital law. Okay, we can write close integration B dot dl is equal to mu 0 ni, and value of this B dot dl we have obtained. Okay, value of this B dot dl is B into 2 pi r. So we can write B into 2 pi r is equal to mu 0 ni. Okay, that will give you b into 2 pi r is equal to mu 0 n I you are getting. Now you can easily simplify this. Okay, we can take the 2 pi r in the denominator, so from 1 and 2 b into 2 pi r is equal to mu 0 ni. Okay, this is 2 pi r, so 2 pi r can be taken in the denominator, so b is equal to mu 0 capital Ni upon 2 pi r, and this total number of turns, n is what? N is a total number of turns divided by the length of this loop. Length of the loop is 2 pi into r, so it becomes the number of turns per unit length, which is denoted by this small n. So we can write mu 0 small ni, where small n is nothing but number of turns per unit length, which is n upon 2 pi r. Okay, so you can see this formula here. Ni is equal to n upon 2 pi r is the number of turns per unit length of the toroid. Okay, in an ideal toroid, when the turns are completely circular, magnetic field at the center and outside the toroid is 0. So magnetic field at the center and outside the toroid is 0. In practice, the coil is helical and hence a small magnetic field exists outside the toroid. Toroid is a very important component of the tokamak used for research in the nuclear fusion. Okay, thank you very much.